my name is Allison Lane, and today I will be doing my fourth video discussion for my CYB659 class at Utica College for Professor Kevin Smith. I will be discussing file signature analysis, but before I begin, one must understand the structure of a file. The structure of a file consists of a file name, a file header or footer, and the file content. The file name is a unique identifier which allows the computer to correctly identify each file stored on the disk. The first piece of information on the file format is given on the name of the file, for example, an essay, a document, a PDF, a GIF, and so on. Different applications use different file formats to encode data on files so that other applications cannot extract the data. The part .doc is the file name extension. The information which describes the type of the file, example, which application the file is associated with, is stored in the header or footer, or both, within a file. Such information is called the signature of the file or the file signature, and they are most often unique to one another, so no two file extensions are the same. The file extension and the file signature of each file should match each other in most cases, but there are a few exceptions. There can be mismatches, no matches, unknown types, and anomalous results. Every file has a file header or footer which contains information on the format of the content stored in the file. It can either form a part of the file or stored as a separate file. Files of a type can be searched for using the information stored in the file header alone. Since the purpose of the file is to store data in different applications, the major content of a file is the data that's normally associated with that application. Such data may be encoded in various ways so that only the eligible applications are compatible and competent to read and extract the content of the file. Forensic examiners during the investigation will come across some unusual extensions or files with familiar extensions that are in pretty much unusual locations. For example, if you have a JPEG hidden in a Word document, you wouldn't know that the Word document contained a JPEG unless you knew where to look or you were aware that one can be hidden in multiple formats. In such cases, forensic examiners can gain some insight into an attacker's technical abilities by using file signature analysis to determine the names of these files, regardless of their extension. Now, the first 20 bytes of a file and the specific signature or magic number will tell the investigator the type and function of the file that it comes from, normally from the collection of information in regards to a file signature analysis. Different file types have different signatures, and these signatures are independent of the file extension. Investigators can use a variety of tools such as ProDiscover, Encase, or Forensic Toolkit, known as FTK, and these tools allow the investigator to readily perform a file signature analysis to easily view the results that they find. After these tools are performed, the investigator gets the file extension that they compare to the signature associated with that extension to the information contained in the first 20 bytes of the file. Files that do not have valid signatures that match their extensions most of the time are flagged for their investigation. This can mean something that was changed or something is hidden or deleted. Whatever the case is, it gets flagged. A good cheat sheet, in my opinion, that every computer forensic expert should know on file signatures or the magic numbers would be Gary Kessler's file signature table found at his website. It's very useful, and forensic examiners can use it to help find the common file signatures for files like a document or a PDF or a JPEG or a GIF, to name a few. Another thing I'd like to note is that JPEG and GIFs, image files, they have their own signatures, so that can be slightly different. Well, that's my take on a file signature analysis. I hope you guys learned something, and I hope you have a great day. Bye!